by Professor Sunahara. So let me introduce Professor Sunahara briefly. He has a long list of achievements related to the development of internet in Japan, and he is learning. He's also learned in BSD and for a long time. So I can describe all here, but so please get started.
Okay, so thank you very much for the introducing me at the start. This is Hideki Sunahara of Institute of Science and Technology. This is the last time to show you that I'm moving to the I'm moving to the new university. Anyway, this is 25th year to using the BSD in my history. So that I selected this title. Anyway, I graduated my university in 1983. So this year is 25 years after the campus life. So the last week we had some party to gathering these 25th anniversary things. And Keio University is very interesting university. So they invited us to the graduate ceremony. So we gathered in the maybe 1,000 people on some places. Anyway, this is the relationship on the BSD and me. I wrote a book called Professional Unix in 1985. Actually, this book is started in 1983, but it takes 2 years to writing these books. Anyway, actually, this book is written on BSD 4.1 and 4.2 things. But we called this book Professional Unix. Since in that moment, Unix means liberty things or free things. So, but after 5 years or 6 years later, we should rewrite these books. Since maybe technology is going very, very fast, so I should catch up the new technology, like notebook PC or the mobility things. So we decided to rewriting these books. But Unix means free at that time. So we should looking for the new good phrase for these book titles. Of course, currently in these days we can select the open source or the open source software to show the free things. But in these days, it is too early to use open source. So we choose the words BSD for meaning of the free. So it's our concept to our works. This is brief history of the myself. In 1982, I met Jim Wright. It's a very bad guy. But he tried maybe Japanese internet world. So I used Unix 7th edition on the LSI 1123. It was very, very low power, maybe small computers, but we used this machine with maybe 20 or 30 people in the laboratories. But we got the new machine in the summer. So I made 4.1 BSD. Okay. And 1983, we joined the development of the SNT networks. SNT-net means a campus net in the Keio University, developed by Jumrai or the Miyoteraka-san in the other peoples. It's a cover the campus-wide networks. But in that moment, there is no TCP/IP. So we developing the from the hardware, that means the Ethernet hardware to the applications. So Terako-san working on the driver of the hardwares, and Murai-san working the maybe layer 3 or layer 4 things. So I hired by Jumrai to writing the application. Okay, so I wrote several kinds of the application, like file transfer and remote logging, and so on. So it's a very hard time to writing program in my life. So it's a very interesting experience for me. Okay, and 1984, JUNET was established. Maybe many people, as you know, Murai-san is moving to the new university, so we need some connection to that university. So we started these things, but this was illegal things. You know, maybe there are some laws to manage the communication things. So we started the illegal things. But in 1985, the law was changed, so we can do such things openly. And 1988 is a very interesting year since we started a wide project. That means Japanese internet started from this year. Okay, so this year, maybe it means 2008 is a 20th anniversary of the wide project. Okay. And after that, we are working several kinds of things. Of course, building the infrastructure and developing some new connection method or other things. But I mainly working on the application side thing, like Internet Car project was started on the in the 1996, and mobile ear. This is a variation of the Internet Car, but this is started in 2004. And we also started some environmental things. That means sensor network. So it was 2005 we started LIVE project. And this year, okay, so this anniversary of the wide project. So we should consider to the next decade. So I don't know that we can establish a 30th anniversary with a wide project, but we are thinking to the next 10 years. Okay, so I'm working on currently these things. One should be the medical things, and another one should be the environmental things. Anyway, this work is same basic based on the same concept. So it's creating knowledge from the small data from the internet. So anyway, I will introduce these works. So at first, I would like to show you the Ethernet Car project. Ethernet Car project is a Ethernet connected automobile research. So it's established in 1996. So we are connecting the several cars and sending emails, but we like to collect several kinds of data from the cars or automobiles. That means there is several information is used on the cars, but this information was discarded. So, but if we can collect this information, we can make more useful information, like traffic jam information can created from this information. So we started several experiments. So we finally got 1,500 taxis which is connected to the internet. Okay. So there's challenge was established in this project. For example, there is some application to supporting the driver and the passengers. Of course, the driver can know the traffic jam from this information. And road condition like slippery courses. So this is very difficult thing since slippery road means can know by slipped cars. So if some cars slipped on the roads, we'd like to know this information. So we collect several information like signal of the ABS, anti-lock brake system, or the I guess that's the case. Rotation. So rotations counts of the tires. So it's a very interesting data. And of course, the driver or the passenger can download some music from the internet, and of course, and some tool management like a toolkit, like a ETC, or the drive-through things like a gasoline station, or the some drive-through drive-through 見せてなんつうっけそう、シャープスだっけダメですね。年取ってダメです、それ。Anyway, and this is very important business chance that collecting this information to some maintenance shops. They can check the car condition, the car health, and they recommend to the change oils or the change tires or that thing. So this is some business things. And of course, we can check some traffic management, like some roads have some bad condition or some heavy traffic jam. So maybe they can control the traffic of the other cars to avoid these traffic jam. Okay, so this is an application of the internet cars. So of course we should develop the two things. One is internet connectivity. So car is moving, so we need some mobile supported communication infrastructures. And of course, we should develop the application. So two things are ongoing. So this is a history of the Internet Car project. In the 1996, there is only one course just installed rack-mounted PCs. So we should starting engine and going to the backside to booting up the BSD Unix and check that condition, and after that we can start it to the driving. And after the driving, we should going back to the shutdown the BSD Unix. And after the shutdown, I can cut off the engines. It's a very, very nasty thing. So we developed a new type of the computer for the automobiles. So this is a new one. So this is also running with BSD Unix. Okay, but this system is automatically booting up with a power on and the power booting down with the power off. And this is a sensor node for the talking the IP version 6 protocols. So this system is connected with IP version 6 and mobile IP version 6. Okay. So this is one of the examples of installation. And there is several kinds of the application. One should be the show location services. This is a tracked data of some cars. So this is a SFC of the K University. So he will coming to the some meetings for the university, but he was going to the McDonald's before the coming to the campus. But he was delayed. So he find this is a very important thing should be the privacy. Okay. So we are currently talking about privacy things. So what is a privacy and what is a not privacy thing? So this requires a international consensus. So we are working on the ISO working groups to define the some consensus of the privacy data. Okay. Anyway, this is one example. And this is another example of the probe data. So we collected data from the cars, is location and speed. So we can make traffic jam information. Red sign shows some slow point. So maybe there is a traffic jam. But blue one means smooth traffic. So this blue sign shows smooth traffic. So maybe we can show a video of the this one. Okay. So this is a transition of the status of the traffic jam things. But this is a nowhere area. So this is maybe main area. So the traffic jam is continued in the all of the days. Okay. But this is traffic jam. But next application is very, very interesting. Since Jim Rai said to me, if we can correct the position of the car and switch position of the wipers, we can know the where is the lane. Okay, so maybe it thinks it looks like a stupid idea, but we do that thing. So this is one of the examples of the lane condition. Pink square shows there's cars, but wiper is not moving. And the blue sign shows there's a car, but and there is of course these cars moving the wipers. So this is very, very interesting things. So you can see some movement of the maybe clouds with a rain. So there are several rains going through in Japan, the cloud moving from the west side to the east side. So you can see some movement of the clouds. This is very impressive thing. Since after showing this information, we got a telephone call from the some weather forecast company. So they said to me, how much costs to get this information? It's a very, very interesting thing. We just idea, and we just working on creating such kinds of interesting works, but they interested in this information. So we interviewed these people. So this is a very, very important thing. Since, of course, we have some weather focusing equipment is installed in the world, in the countrywide in Japan. But this sensor is located in each 20 kilometer. So this is a very, very important information since it's a very narrow area weather information. So they want to buy this one. So currently they are joining our project. So we are talking to this information for other people. So next one. But these systems have required many costs, especially the communication costs. So we used a cell phone to collecting this information. So we need maybe 5,000 yen per car per month. So how much cost to establish 1,500 cars is a very, very large cost. So we should collect these costs from the several places. So we should have some business chance of the other things. So why we installed this system to the taxis? That means that the taxi needs some controlling to the assignment of the cars. So this is one of the applications for the taxi companies. So they have the call from the customers, and they assign the cars to the any places with these informations. So this is an example of the taxi location services. So maybe blue sign shows it should be that empty. Operators. There is a taxi with a customer. So it's not enabled to assign to some other customers. So, but red sign shows empty taxi. So operator can select the nearest taxi for the customers. So they can reduce the time to the allocation of the taxis. Okay, and some taxi it's some in these experiments there is some troubles from the taxi cabs, and that is some days some taxi one taxi couldn't send their location to the centers. So we are checking to the taxi cabs, but there is no troubles, and there is no errors. So we interviewed the taxi drivers of that cabs. So he said to me, "Sorry, I wrapped the antenna of the GPS with army hoils." So they think that managing by the company is a very, very hate thing, so that they don't want to do such kind of things. So they did such kind of things. So, but after that, I said that the merit of the taxi drivers. So this is a application for the taxi drivers. They should write a diary for the driving data. So from where to catch up the customer and where to go. So, but this system can generate automatically these things. So after that, they cooperate to us to further these experiments. Okay. So after that, I installed 1,500 taxis, and we enjoyed these experiments. So this is another example of the one traffic jam data of the 1 day. Okay. After that, I did several kinds of feasibility studies. So this is a slippery data feasibility. And currently, we can see these data at the Akita area. Akita is the north side of the Japan countryside of the north area. But there's a heavy snow, so there's many accidents by the sweeping cars. So we are collecting these data from the cars, and we show these data to the internet. It's called the service name. The service name should be the Tsurunabi. Tsurunabi doesn't mean the ski head. So this means that Tsuru means a crane. But it also means a sweeping thing. So the Tsuru navigation system is already exposed. Okay, so this is a result of these things. Okay, and this maybe all of the people doesn't understand how to correct these data from the cars, but current cars already have the networks called CAN, control area networks. So we can correct these data from these interfaces. But sometimes it was encrypted by some codes. So we should cooperate with the car manufacturer to realize this. But we can correct such kind of these data, so we can create a more efficiently and more useful data information from these data. Okay. So if you have some idea, please let me know. Please cooperate to do these things. After that, I got some idea from my city people. And in Japan, ambulance and fire department is controlled by city. So I talked with these people, and we started project to connecting the ambulance to the internet. So on this project, we can establish a communication between the doctors in the hospital and some people, some staff in the ambulance. So to help to the working some helping the people. Okay, so of course there is several sensors like ECG, electrocardiogram. I don't know exactly pronounce the ECG. だって心電図ですね。ECG and the blood pressures and SpO2. That means this is a percentage of the oxygen in the blood. So this is very important information. So SpO2 and heartbeat and breast count and so on. So we connected these equipment to the internet from the ambulance. Okay. And currently they are using many cell phones to connecting these things. So ECG has its own cell phone, and GPS has its own cell phones, and ambulance staff is also using a cell phone to communicate doctor. So we reduce these things, so replace to the internet. So okay. Oops. So this is a current system. So we call this system mobile ER, and so staffs wear a computer with a camera and display. So they can do their works without disturbing some operation of the computers. So and they communicate with the doctors, and the doctor can see any information from the ambulance. And it's difficult to communicate only with the voice, but we also send video information data. So doctor can command to the staffs. I would like to see this point, like this way. So the video communication is very, very important on this system. So this is wearable computers installed to the staffs of the fire department and the ambulance staffs. And we also installed mobile router and other computers running with us, several things. Actually, this mobile router is running with a BSD. Okay. And we also, so this is a image of the services. So doctor can communicate to the ambulance staffs, and the doctor can command several things. So of course they can see the ECG or the heart rate and the CO2 data on their displays. Okay, so this is some of the images of some data, and this is a doctor view of the in the hospitals. This is a heart rate, and this is a SpO2 data. And there is videos and command data from using the videos. So this is actual equipment using the ICT. This is a server is running with ARM processors, but of course this is running with a BSD. Okay, and this is ECG and communicate with the internet. And this is mobile router running with BSD. Okay. After that, I would like to move to the some countryside medical support. Since Nara area has a very, very wide but very sparse village in the south side, so we support these people for some healthcare or the medical support. Okay, so another one is a Live E project. Live E means Earth or the environmental things and so on. So this is a sensor network project of the worldwide. Okay, and basically we are installing this digital weather station in the worldwide, especially in Japan. This project started from in Japan. So we already installed 100 sensors in the world. Currently, maybe 80 or something like that. Weather station was installed in Japan, and we also installed Taiwan and Philippines and Indonesia and Thailand, and we also installed Canada, and we are currently talking with French people to installing these sensors to the French side. So maybe if you would like to join to this project, please talk to me to some cooperation. Anyway, we already installed 100 sensors. So this is a server management, like a tree-style thing. So since we would like to deploy it to the worldwide, so we needed some distributed management of these servers. Okay. And we also made a middleware for sensor nodes. There is several types of sensors, so we need develop some sensor node like for each kinds of sensors. So it should be very, very difficult thing. So we developed some description language with XML, and we installed middleware these systems. So we can write some XML to add the new sensors to send this information. So, of course, this is also running with BSD. So, anyway, this is very, very interesting thing. So, we also working on the P2P networks. This is not sharing the illegal data, but we would like to share these weather information or the environmental information data with a P2P network. Since there's too many nodes will be in the world, so we cannot manage anymore with a client-server model. So we also working with a P2P network things. So, but we also continue to manage the server client style services. So we developed some multiple fan-out systems for the several sensor nodes. So we working with client server nodes. Concurrently, we are developing some challenge for the P2P networks. Okay, this is example of the things, and we also working with some mobile ad hoc network things. Since some places we like to install the weather station. Shows that there's no infrastructure for the communication. So we need some collection method to collecting the information from these sensors. So in this challenge, we use the elephants. Okay, Thailand have very many elephants for some cooperation with the humans. So we selected like this way. So elephants. So elephant can install there's bugs in some computers to collecting the data from the sensors. So this is the example of the elephant node. Okay, these are elephant node. So please see much more here. So he has a collecting nodes. This is also collecting nodes on the backside of the elephants. So, of course, the sensor is located in the fixed point. So, elephant working around there, so they can collect these data using the money technologies. Okay. So, and the collected data is collected to the fixed point, which have the satellite communication links, and directly connected to the Bangkok center. Then these data is collected in the server in the Bangkok. This is a challenge of Danbo. Okay. This is a autonomous fixed sensor node. So there's battery and Wi-Fi communication point and computer. So and sensors. This is sensor. So we install these sensors like this way without no infrastructure. Of course, battery can supply the power and the communication with continue with elephant nodes. Okay, so this is a fixed sensor. So this is a deployment system, and we could collect these data very hot days in the Phuket Island. So this is a graphs of the some data. So I have 5 minutes. Okay, but I want to go to this experience, but I have some meetings, so I can't go to meetings. So my students is going to this project. But there's some strange photograph is collected from my things. They enjoy these things. Anyway, this is the current status of our project. And currently, library project just collecting these data from the sensors, but we would like to start how to use these data. So this data can use for the reduce the consumption of the energy, like electricity or some other power. So we start green Nigokan project. Nigokan means some second building of the University of Tokyo. So they got a new building in the campus. So this campus is controlled several things with the IP, like power switches or some air conditioners and so on. So we decided to use a model case of the using these weather data or the environmental data to reduce energy for this building. We also maybe started at Hiyoshi campus. Hiyoshi is one of the campus of the Keio University, but we also get a new building for this campus, so we started the same things on the Keio University. Anyway, this is a maybe new trial to use environmental data to reduce energy consumption. Okay, so maybe I have 5 more minutes. So as you know, you already have a news from us. So I don't want to say such things, but I would like to say these things. I should say these things to everybody. This Itogen was gone in last October. This is very, very sad news, and I can't believe these things yet. But this is actual real things. So we should know these things. But he dreamed new IP version 6 world. So we should continue this work with him to realize a more wonderful, nice world. So we started planning the next 10 years for research plan in Y project. So so we promised to him to make a wonderful world with a IP version 6. That world should be the wonderful places who he would like to come back to here. Okay, thank you very much for my talks. Thank you. Thank you very much.